I hope that I can remember that we have started these integers and logarithms. And have we finished these integers completely? Chamalka? Make your correction. Shall I leave you out of the class? Class in on the end of the Naki Katakaranda?
Solving equations with indices strings and multimeter කරලා තියෙනවා.
Indices, equations with indices that means okay. So we have to start with logarithms, right? Yes. So we will move that. So first part of the second lesson is done. Right. Okay. So write the subtopic. So our next part is logarithms. And the basic subtopic of that is laws of logarithms. Okay, all of you write logarithms, and then we are learning about the laws of logarithms today. Okay, so you have learned some logarithms in grade 10 as well. So there are several laws that you have learned. So I will give you a brief about these laws that you have learned. So by taking the first one, if you have a product in between two logarithms, right? You can simply write that one as an addition in between those two terms, right? So log m times n to the base a is equal to log m to the base a plus log n to the base a. This is vice versa, right? ඒ කියන්නේ addition එකක් multiplication එකක් විදිහට ලියන්නත් පුළුවන්. multiplication එකක් අපිට ඕන වෙලාවට addition එකක් විදිහට convert කරගන්නත් පුළුවන්. The opposite exact opposite one of this one is the divisions. So log m divided by n to the base a will be equals to logarithm of m to the base a. Now the numerator one will be written first, and the denominator one will be written second, and it is being subtracted, right? And the other one which you have learned is logarithm of any number to the same base will be equals to 1, right? And the other one is logarithm of 1 to any base is always equal to 0. So these things you have learned basically in grade 10. Right now we are going to learn about some other rules which are much similar to these rules. So to get familiar, I want you guys to write the things that I have written in red. Okay, so laws of logarithms. So logarithm of m times n to the base a will be equals to the addition of that, and the division will be equal to subtraction. And then logarithm of a same number. Now here a will be a number, right? So a to the same base. Then මෙතන පහ තිබ්බනම් මේක පහ නම් ඒක equals to 1, right? Make it derivation එකක් මම ලිව්වොත්, let me write in blue, right? If I write in a blue, so logarithm of 10 to the base 10 will be equal to 1. ඔන්නෝක තමයි මේකේ තේරුම. හරි? Okay, guys, you may write this quickly. Laws of logarithms. Hurry up and write it. Right? If you have not written, please let me know. Huh? So we'll be moving. So moving into the fifth one, that is something new that you will be learning in grade 11. Right now, if you have logarithm of 5 to the base 2 to the power 3. Okay, so if you write this one in this manner, right, logarithm of 5 to the power 3 කියන එක කෙනාව දැන් expand කරලා ලියනවා, right, within a bracket. 5 to the power 3 means 5 times 5 times 5. Is it clear? Right. Why 5 to the power 3 means 5 should be multiplied 3 times. So it is 5 times 5 times 5. Right now, here if you apply the first law of logarithms where multiplication can be turned into an addition. So if you apply that case over here, so it has the same base. So it will be converted to logarithm of 5 to the base 2 plus logarithm of 5 to the base 2 plus logarithm of 5 to the base 2. Right now, can you see that there are three identical terms? මේ එක වගේ තුනක් තියෙනවා පේනවද? Right, නිකන් හරියට නිකන් x ඒවා තුනක් එකතු කරලා වගේනේ x plus x වගේනේ. එහෙම වුණා නම් අපි කොහොමද ඔක ලියන්නේ? එහෙම එකතුවක් විදිහට ලියලා තියෙනවා නම් you can write it as how 3 times logarithm of 5 to the base 2. Is it clear? Right, so in other way you can write 3 log 5 to the base 2, where times means here it is 3 log means it is a product. 3 වැඩි වෙන්න ඕනේ මෙන්න මේ value එකෙන්. Right, logarithm of 5 to the base 2 කියන එක හොයාගෙන ඉවර වෙලා 3ෙන් වැඩි වුණාම ඒක සමාන වෙනවා logarithm of 5 to the power 3 to the base 2. Right, ඇත්තටම මෙන්න මේක දිහා බැලුවොත් what can you identify? What has happened actually? Now this 3 over here has moved in front of this. Right, so simply what can you see in here is this 3 has been moved as a product. So ඒ කියන්නේ මෙතෙන්ට ගිහිල්ලා නේද? ඒ කියන්නේ සරලව ගත්තොත් අපි මේක මේ පැත්තට අපි ගමු මෙහෙම කියලා. Right, මේ 3 කියන එක move වෙනවා මෙන්න මේ ඉස්සරහටනේ. Can you see that? Right, therefore in general you can write this. Now this is not in general, so this is something like this. So this is right. Okay, not that one. So if you consider a general case, right, logarithm of m to the power n to the base a will be equal to, now this n will be moving in front, n log m to the base a. Hope you understood the thing. So this is the general form. So I want you guys to write this and make it as the 5th law of logarithms. Hurry up and write. Starting from the top, you may write 5th law out. Start from here. Okay, hope you have written it. So if you consider some examples regarding this, right? Something like this. I mean, write some examples of this law. Logarithm of what can be written? 12 to the base 5 to its power 3 can be written as, from then 3 log 12 to the base 5. Right? So if you consider logarithm of 6 to the base 5, and 6 to the power, we'll think it has a fraction. 6 to the power half. Now tell me, who will be the one which is being multiplied at the front? Easy. Sorry guys, small interruptions. Right. Okay. So tell me, Shalika, is the one going to be over here? Is 2 going to be over here, or entire half going to be over here? Yes. Logarithm of 6 to the base 5 here. Who will be in here? Hurry up and tell me. Shalika, can't you hear me? Oh, you are not there in the class. Staying silent, I will assume that you are not in the class and I will remove out you. Yes? Okay. I got an answer. Another answer. Shalika, you are not responding? Gedre gonna Harina. Sikra, what do you say?
Half log 5 to the power 6.
No, half is correct. The way you read the other part is wrong. Huh? Half log 6 to the base 5. Okay. You
2
read.
to the power 3.
Huh? No. No need. What? 2 to the power 3? Where? The way you read this part is wrong. Actually, the number which comes in front of this one is half, entire half, or exactly the exponent number over here, maybe a fraction, maybe a whole number, should come in front and get multiplied, right? And the way you read this one is wrong, right? You read it half log. First you read this 6, and then here this is the base. So log 6 to the base 5. Okay. So it is read as half log 6 to the base 5. All right, base is 5. Okay, so this is the base. All right, so much similar one. Let's have a look at another one. If you have okay, something like this, logarithm of square root of cube root, okay, square root of cube root of 15 to the base 2. Now, how could you write this one in this format? So cube root means that we have learned in the previous session about indices. What is the power of the cube root when it comes to a power? What is the answer when it comes to power? If I ask from Chamalkar, Nirman, what do you think? If it is a cube root, what is the power of that? No idea? Yes, you missed. I think you have missed a session, so I did teach you on that session. Okay, anyhow, so you can write this one, logarithm of 15 to the power 1 upon 3 to the base 2, right? A cube root can be written as power of 1 upon 3. Okay, so now much similar to this example right now. So what happens? Who is going in front? It is 1 upon 3 and log 15 to the base 2, right? Okay, examples. I'm not giving additional time, so you can write it on this itself. Logarithm of, I will write another one, square root of 20 to the base 5. Not 5, we'll take another one. Base 3. So how could you write this? Now you have a square root. If you do have only this square root symbol, then digit over here is 2, no? I have teach you in the previous session, right? Therefore, you can write it logarithm of 20. So the power, it becomes half over here, right? When you had 3 over here, this become 1 upon 3. Similarly, if you have 4 over here, right? Let's take another example later. If you have 2, or if you don't have any either digits, it is 2, right? So it is obvious, so you can write it in this manner. And logarithm of 20 to the power half to the base 3, right? Now you have a power over here. Simply you can take it in front and multiply with this. You need not need to write the product. Half log 20 to the base 3 should be the answer. So simplification is separate thing. I'm just teaching the law, this law. Make a simplify right? So I'm just teaching you the law, right? Don't bother about the simplification of this, right? So just I'm teaching you the law. That's all. So let's take a look at another example. All right. So this is about that law, and we will go for further examples having the same thing. Hope you guys have written the very first few examples. If not, let me know. I will not scroll up. If you have not, if you have done, I will scroll. I will just go downwards. Is there anybody who require more time? So the students has finished. So let's move in. I will give you some examples which you can work out. Find the values of the followings: logarithm of 8 to the base 2, number 2, logarithm of cube root of 27 to the power base 3, right? So you can use these laws which you have learned separately and try it by yourself. Logarithm of 2 log 10 to the base 10 plus minus 2 log 100 to the base 10 plus log 3 log 10 to the base 10. No, wait. Plus 3 log 1000, 3 log gold. We'll just write